So in this video we're going to look at how to differentiate from first principles. I'm not explaining here how to derive first principles or how to find first principles, but only how to use them. So the question will be differentiate that from or using first principles. And the first thing you have to remember is that we're working with this expression here, that the derivative is equal to the limit as h approaches 0 of f of x plus h, and if you remember, h is that little bit above the point we start with, but I won't go into that in this sequence, minus the function of x all over h. Now my suggestion is just concentrate on finding these two things first, and then we can put them together in a fraction. So what I've done here is I've started with f. What does this mean? Okay, well, if I had, for example, if I had f of 3, you would use this 3 and place it into the x. And it's essentially the same thing, that we're going to use f x plus h and substitute it into each one of these x values. Okay, so let's have a look how to do it. And it's going to just sound a bit clicky, unfortunately, or perhaps because of my pointer. Okay, so that equals, now 3x squared means that we put x plus h in place of x minus, now I'm just going to put these in brackets just to show you where all this stuff's going. And it's good to put it in brackets too, because it's a minus, and that way you won't get confused or you won't miss a negative sign when it appears. Okay, so that equals, now all we have to do then is expand it, and we've got, let's squeeze this 3 in. Don't try and get the 3 in at the same time. Square the first, square the second, twice the first by the second, so it's 2xh. And then we've got minus, and this is what I meant by don't expand it all at the same time, minus x. So we've got minus x and minus h here, so that's minus h plus 1. Okay, and that, well, I'll finish this off now. So we get, and that equals 3x squared plus 6xh plus 3h squared minus x minus h plus 1. Okay, and that then is my expanded expression. There's nothing here there's no like term, so I can't simplify that. But that's what will end up in here. Now, let's just concentrate on this for a second. F of x, well, that's just this thing here. So I'm going to see if I can't get my pointer up here. Let me just try this. Okay, so that equals, and as I said, it's just 3x squared minus x plus 1. Okay, now what we're going to do is we're going to go back to here now and put this all together and put it over h. So, okay, so here we go. So we've got dy dx equals the limit as h approaches 0 of, now I'll just do the numerator first, it's 3x squared, you get the idea, right, plus 6xh plus 3h squared minus x minus h plus 1 minus, now just, again, I would just recommend the bracket here, although I know you can do it first go, because we times the minus to the 3x, the minus to the minus x, and the minus to the 1. So, okay, for the sake of expediency, I'm actually going to do that. So that means I need to try and get rid of this bracket here. Great. And we'll keep going. Minus 3x squared plus x. Now, you know, this is where students make a mistake when they try and expand with a negative on the fly. Okay, so just be careful, and that's going to be all over h. So let me try and place that. I'm just going to put a line there because it's the tool I'm using is just a bit tricky to get that whole line there. Okay, now what we're going to do is, again, the limit remains because we haven't used it yet, so it's h approaches 0. Now I'm looking for like terms. 3x squared minus 3x squared, well, they cancel. I've got a 6xh here, and there's no other xh's, so I've got 6xh. I've got, so I'm going to, that has cancelled with that. I've used my 6xh, so I'll just put a line through that. I've got this thing here, 3h squared. I've got a minus x there and a plus x, they cancel out. I've got minus h there. Use that, and 1 minus 1 is 0 over h. Now, next I factorize. I mean, the rest of this is just algebra with some limits here. H outside of 6x plus 3h minus 1 over h. Of course, h's cancel. We have the limit as h approaches 0, I've got the 0 up there, of 6x plus 3h minus 1. Now we can use the limit, okay, and that means that h equals 0, that becomes a 0. And so what we end up with is, once I use the limit, I get 6x minus 1, and that's my answer. Okay, now if I were to go back to the top and have a look at the original question, then what we would see, if I can do that, not easily, but what we would see is that the derivative of the original question, like if you just use normal differentiation of 3x squared, okay, we started off with 3x squared. Well, the derivative of that, when you bring the 2 down, bring the power down, multiply it by 3, we get 6x. We had minus x plus 1, I think it was. Well, the derivative, sorry, that shouldn't be there. Let's get rid of that and start again. Minus x plus 1, just to finish off. The derivative of x is 1, and the derivative of 1 is 0. That's it. This is it using first principles, and really it's just about, let's substitute x plus h into the equation and do that. We find f of x, we subtract the 2 over h, and always h will have to cancel because I can't substitute a 0 into a denominator. So if you don't get cancelling h's at this point, you've made a mistake somewhere and you need to go back and find it because you can't have a 0 as a denominator. And of course, the good thing about first principles, just to finish, is that you know what you're aiming for. If I start with this, I know how differentiation works and I know what the answer should be, so it's giving you a hint about how to get there. Okay, so there is differentiation by first principles.